So here's an example of a fractional equation or algebraic equation involving fractions. And the easiest way to take care of these things is multiply both sides of the equation by the least common denominator. It's going to get rid of the fractions. So first of all, we have to determine the LCD. So we want to be able to build our LCD, and we usually build it out of factors. So first of all, we're going to make sure that everything's factored. So remember, always first factor the denominators if they're not already factored. So factor the denominators, and this one's already factored. It's one binomial factor, so I've got 2 over x plus 3 plus 1 over x minus 7 and 4 over, and this looks like a simple trinomial, so I'm going to factor this. X and x. Now I look at this sign here. This tells me that these two signs will be different, and if they're different, this tells me the sign of the larger, so I usually put the larger on the left. You don't have to, but that's what I do. And I need two numbers that multiply to give 21, and since the signs differ, they differ by 4. That's going to be 7 and 3. And notice that those are the two factors that appear in this fraction and this fraction. So when we build our least common denominator, our LCD, I'll just try the largest one first. X minus 7 times x plus 3. And notice that you can see x plus 3 right here. You can see x minus 7 right here. So both these denominators fit or factor or divide into this LCD just as this does. This goes in once. If I divide this by x minus 7, I get x plus 3. If I divide this by x plus 3, I get x minus 7. So all the denominators divide into the LCD. So that's what I multiply both sides by. So I'll rewrite my fraction, my equation, so you can see that. And we have to multiply every term by the LCD. So I'm going to multiply this by multiply this by, and I'll multiply this by. So multiply every term by the LCD. And when we do that, we can see that x plus 3 over x plus 3 is 1. So what's left is 2 times x minus 7 plus, and then x minus 7 over x minus 7 is 1. So what's left is just 1 times x plus 3. And then we realize that x minus 7 over x minus 7 is 1, and x plus 3 over x plus 3 is 1, so we just have 4. Now, that's a lot simpler than that. So multiplying by the LCD took care of all that. Now I just have to multiply out and solve for x. So I've got 2x minus 14 plus x plus 3 equals 4. And then 2x plus 1x is 3x, so I got 3x. Negative 14 plus 3 is negative 11 equals 4. Then if I add 11 to both sides, I get 3x. Equals 15, and if I divide both sides by 3, x equals 5. I almost forgot the restrictions on our domain. We have to go back over here and check, and we know that any value that will make the denominator 0 is a restricted value. We can't have that. It's a no-no. So x cannot equal negative 3, and x cannot equal 7. 7 minus 7 is 0, and negative 3 plus 3 is 0. We can't have that. So these are the restrictions on our domain, and we want to check because sometimes you get an answer that's restricted. This is not restricted. X can be 5, so there's my solution. And you can go back and check it. Shouldn't be any problem. So remember, these two steps, Make sure the denominators are all factored, and then build your LCD, your least common denominator. Then multiply both sides of the equation. That's every term. Terms are joined by positive or negative signs. Multiply every term by the LCD, and then you're going to have a nice simple equation to deal with after that. Although sometimes it might be a quadratic.